Hello, this is Yuri from Visual Components. In this tutorial, I will cover the basics on how to use the LS Electric connectivity plugin.
When following any tutorial, check the lesson in the Visual Components Academy, and if the Download Files option appears, you can download the example files.
The LS Electric plugin is used to exchange data between Visual Component simulation and a LS Electric PLC. The PLC can be either a hardware PLC or a simulated one. In this tutorial, I am using a simulated PLC running inside the XG5000 PLC environment. You can download the files used during this tutorial from the Visual Components Academy next to the video. To use the connectivity plugins, you must have the connectivity add-on enabled. File, option, add-on, connectivity. After applying the change, you need to click OK and restart the software. Note that the LS Electric plugin requires you to have Visual Components Premium version 5.0 or later. For additional details, please check the Visual Components help documentation. I have built a simple test simulation based on a physics feeder and a pusher conveyor. The feeder provides parts to the conveyor at 1 second interval. The conveyor has a sensor that detects parts and provides input to a PLC that will control the pusher. Now that I'm running the simulation without any PLC connection, this cylinder is doing nothing since there are no connections active. I will now switch from Visual Components to the LS Electric PLC programming environment XG5000. Here I have created a simple PLC program using structured text. The program reads a Boolean sensor input and detects the rising edge. For every other rising edge, the program will activate the cylinder. When the cylinder is fully extended, the program sets the output to false so that the cylinder will return back to the neutral position. All the variables for this program are defined in the local variables section. Note that I have assigned the addresses to the M memory area so that they can be accessed by the communication plugin. The LS Electric plugin does not support browsing variables, so I must export the variables from the XG5000 project to a file. I can do this by going to Project, Save Variables to File, and then checking that the global as well as the program local variables are selected. Then hitting Save and saving the lsplc.csv file. The file is now saved to my LS Electric project file or folder. Next, I will start the PLC simulator. This will also write the program to the simulated PLC. OK. Writing completed. And then I will ensure that the run mode is active for the simulated PLC. So now we see that the program is running inside my simulated PLC, and we are ready to switch back to Visual Components side. Here, I'll choose the LS Electric connectivity plugin and click Add Server either from the top toolbar or by right-clicking on the plugin Add server. Then on the right hand side, I have the option to define the host IP address and port number. For the simulation PLC, these default values can be used, but if you have a hardware PLC, then you need to change these values. Now we can test if the connection can be established. Connection succeeded. And then finally, we need to click Apply to save the connection. Next, I will enable the connection either by pressing on this Connect button or by clicking on this Reconnect while having the server connection selected. Note how this icon turns green to indicate that the connection is currently active. Next, I need to load the PLC symbols from the exported file. So I will now navigate to the project file, project folder, and select the lsplc.csv file. And then we are ready to start pairing the variables. So first, let's choose the simulation to server direction. I'll right click, choose Add Variables. This will open the Create Variable Pairs window. For the simulation to server direction, I want to select the pusher conveyor raycast bool signal. So this is the sensor that detects parts. And then for the PLC side, I'll pair this with the sensor boolean variable. Also, for the pusher component, I will choose the closed state signal and pair that with the cylinder extended variable on the PLC. So these are the two values I want to transmit from the simulation side to the PLC. Now I can close this window, and since we are now only moving two booleans, I can switch the update mode for the simulation to server variable group to be event-based, so that there will be less traffic and higher response times. The event-based mode is only supported for the simulation to server mode, so unfortunately for the server to simulation, this mode is not available. But we can still use the cyclic mode, so let's also pair the variables from the server to simulation. And here we want to get the cylinder actuation command and then pair that with the physics pusher push joint action signal, like that. Now we can close the Create Variable Pairs window. Now I will expand the Connected Variables window, and we will see that some of the variables are synchronized. If you don't see this, you can toggle the server connection off, on, and then start the simulation, and then the variable synchronization should start. So we are sending the sensor signal to the PLC, and then for every other trigger, the cylinder is activated. And we see that down here in the connected variables. We can also see how it looks like on the PLC side. So we are seeing sensor go from 0 to 1, part count incrementing, and then the cylinder going also from 0 to 1. Now we can use the simulation to test the PLC logic and to verify that the actuator has enough time to extend and retract between the parts. For additional details, please check the Visual Components help documentation. This concludes the lesson. Thank you for watching.